right, so now let's take our information from the other side and let's write them in theorems. We're going to write them as conditional statements. So here's the first one. Corresponding angles postulate means we don't prove it, it always happens, and we showed how that works. It says if a transversal intersects parallel lines, then corresponding angles are congruent. Now, I don't know about you, when I'm writing a reason, when I'm doing a proof like we did with our algebraic proofs, I don't want to have to write the whole thing out. So we actually created a shortcut using all the symbols. If parallel lines, remember the arrow means conditional statement, so if parallel lines, then corresponding angles are congruent. So really memorize the shortcut way of writing it out, because it will save time even on homework. Like when you have to tell why, it's a lot easier to write your shortcut method out than writing all the long words out. So here's what they're telling us. If you're given a parallel lines, you should be, right away, here's my parallel, you can automatically assume that corresponding angles are congruent. So you should be able to get, basically, how many pairs? You should have 4 pairs of corresponding angles be congruent. And you automatically can assume that anytime I say these lines are parallel. So keep that in mind. And then we have our alternate interior and alternate exterior angles. I put them in the same thing because basically the theorems state the same thing and we had the same type of pattern. If a transversal intersects parallel lines, then alternate interior angles are what? Congruent. And also alternate exterior angles are congruent. So the fact is they're not congruent to each other, but their pairs are. So we can keep that in mind. So I want to have a shortcut way of writing this one out too. I want to make sure I know those. So first one, if parallel lines, then alternate interior angles are congruent. And then your other one would be if parallel lines, then alternate exterior angles are congruent. Now, hopefully this makes it really easy how to see these. So again, first thing, the given information is, now I'm going to start saying a lot of givens all the time. That means this is information that's true. Line R is parallel to line S. I have the 2 parallel lines. Well, alternate interior angles. Which 2 angles were alternate interior? Well, that's like 3 and 2. They're going to be congruent to each other. And I also are going to have the fact my alternate exterior angles are congruent. And those 2 are going to be congruent to each other. Remember, alternate exterior are the ones that are farthest apart from each other. So you're going to get, again, pairs of congruent angles. All right, our last theorem, and then we're going to do some examples. Same side interior angles. Now, guys, in class, I tell you I make a fool of myself, and I do a little dance to help you memorize this. So just remember the same side shuffle. Always know that same side interior angles, and use the repetition of the letters. Same side interior angles are supplementary. And any time that you don't remember this, I'm probably going to do the dance in class, so make sure you have those down. So if we have parallel lines, then same side interior angles are what? Supplementary. So again, this shortcut method, I can't sit there and say because they're same side interior angles. No, because same side interior angles don't have to be supplementary. If I don't have parallel lines, they're not supplementary. So we have to be able to justify our reasons. And then the example that we're going to use here are going to be our 2 angles right here. If my 2 lines are parallel, then we should know that our same side interior angles are going to add up to 180 degrees. That will save us so much time. All right, let's flip the page over. And let's start with number 10, because we did 1 through 9 earlier. All right, now it says, find the measure of angle 1 and then the measure of angle 2. Justify each answer. Well, let's do angle 1 first. And now again, I'm going to use the shortcut methods of writing this out, so keep this in mind. So first of all, how do I find the measure of angle 1? Well, I notice this angle and this angle are alternate interior angles. And my lines are parallel. So I know the measure of angle 1 is 100 degrees because, and now here's how you justify your answer. If parallel lines, then alternate interior angles are congruent. Now, how about for the measure of angle 2? Now, here's the cool thing. Angle 2 has the same measure, so I'm going to use one arc as my 100-degree angle. But I'm not going to use parallel lines this time. That's actually a waste of time. Instead, for the measure of angle 2, I'm going to say it's 100 degrees because of the vertical angle theorem. That is still legal to use. As long as we've had it, it's true, we could justify it that way. So we want to keep that in mind. Then we look at number 11. Once again, how are we going to work with these? Well, look at my two angles right here. And if you need to, there's nothing illegal for flipping your paper over. Because when you do that, you see the Z shape of the alternate interior angles, and then they're going to be congruent to each other. So I go over here then and say, well, I know the measure of angle 1 is 75 degrees. But again, it's because if I have parallel lines, then alternate interior angles are congruent. Now, another thing though, how do I find the measure of angle 2? Well, do you guys agree with me, and I'm going to use a red mark here now, that those two are corresponding angles. They're on the same side of the transversal. One's exterior, one's interior, and they're non-adjacent. And remember, corresponding angles are congruent. So I go, oh, I know the measure of angle 2 is 75 degrees because if I have parallel lines, then corresponding angles are congruent. So the reasons don't change. Well, let's do the next one. Let's look at angle 1 here. Well, look at these two. Are those on the same side of the transversal? One's exterior, one's interior. Yes, those are alternate exterior angles. And if I have parallel lines, which I do, then I know my alternate exterior angles are congruent. So the measure of angle 1 is 135 degrees. Now, guys, still have to justify it. That is part of your homework. This is also on a quiz, and this is also going to be on a test. So don't forget that you need to know how to do this. So we have parallel lines tell us what, or parallel lines imply alternate, excuse me, I said alternate, it should be corresponding, excuse me, corresponding angles are congruent. Now, we do have a pair of alternate exterior also. That's 2 and my 135 degree angle. So the measure of angle 2 is equal to 135 degrees, but the reason would be if parallel lines, then alternate exterior angles are congruent. Now, please note, this is how you do your homework, this is how you do your quiz, this is how you're going to do your test. Justify means you have to use the right theorem, and you have to know where you start. And on this one, if I start with the lines parallel, that's my conditional hypothesis every single time. Now, on 13, 14, and 15, you are asked to find the missing variables. We have to use the fact of what we know about parallel lines in order to do this. So here's my rule. If you don't see it, change the diagram. So like here on the first one, here's my parallel lines. I'm going to extend them. Notice when I do that, all of a sudden I have my two parallel lines and a transversal. Well, if that's the parallel lines and transversal, what type of angles are those two angles? That's right, same side interior angles. So then they are what? Remember the dance. Same side interior angles are what? Supplementary. So I can go x plus x minus 26 equals 180. So 2x minus 26 equals 180. 2x is equal to, in this case, would be 206. X equals 103 degrees. So what are the measures of my two angles? This would be 103 degrees, and since they're supplementary, can I just 180 minus 103 and get the fact that's 77 degrees. Now, let's do the same thing for the next problem, except for I'm going to take a moment first and redraw it this way. So I'm going to extend this. I'm going to extend it going this direction. And there we have our parallel lines. Again, now if this is my transversal and these are my parallel lines, aren't those same side interior angles? And same side interior angles are what? Supplementary. So I can go over here and go, all right, x over 2 plus 7x is equal to 180. How do I get rid of that lovely, lovely 2? Multiply everything by 2. X plus 14x equals 180. You have 15x is equal to Yeah, I'm thinking here, sorry. 180 divide by 15. And I do believe, I think that's 12, but let me double check real quick because I don't have you guys to help my math here. Yep, it's going to be 12. So now I can plug it in. And yes, this isn't drawn hugely to scale, but we can plug it in, plug it in. All right, so what do we get here? X divided by 2, so that's 12 divided by 2 is 6 degrees. Well, if that's 6 degrees, and they're supplementary, I should just go 180 minus 6, which is 174 degrees. Are you guys starting to see the patterns here? Let's look at the next one. I still need to extend, and I'm going to go this way. And notice where they're telling you this angle is located. It's located right here. And you're going to notice the marks I make there real quickly. And here would be my extension here. Look at it like this. Do not let this line confuse you. Cover it up. Here's a transversal. Here's two parallel lines. What type of angles are these two angles I just marked right here? They're corresponding. And then we go, okay, if I have parallel lines, corresponding angles are congruent. We have to think if-then process. So I set them equal to each other. 3x minus 5, equals x plus 55. Okay, so then I solve for it. I'm going to move the 5 over, so I get 3x is equal to x plus 60. I'm going to go ahead and move the x over, so 2x is equal to 60. Divide by 2, x is 30. All right, so that's x, but it says solve for the angle, so plug it in, and I get 30 plus 55. That's 85 degrees. Well, if this one's 85 degrees, what's this one have to be since they're congruent? 85 degrees. Wonderful. Now, the next thing is actually a geometric proof. And you have all the skills to do this, but you need to remember how it's built. Now, we're trying to prove that angle 1 is congruent to angle 3. And we're given the fact we have parallel lines. So we will always start every proof with the given statement. So, and I always mark it on the diagram. Then notice the next step that they're going to tell you. They tell you angle 1 is congruent to angle 2. Why are they congruent? They're what type of angles? Alternate interior angles. And since the step before tells me they're parallel, I'll just go, all right, parallel lines, then alternate interior angles are congruent. Now, they also tell me that angle 2 and angle 3 are congruent. Well, angle 2 and angle 3, how are these congruent to each other? Now you guys are going, I don't know, I'm fried. Here's the deal. They're vertical angles. Always look for vertical angles. And that's the vertical angle theorem. If two angles are vertical, then they are congruent. And then our last step, look what they did. They go angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. Now angle 1 is congruent to angle 3. This is like our LS, right? That's your transitive property. And you've just done the proof for this. You guys did a great job. So you got a proof for showing the angles are congruent. You guys did a good job on this. Hopefully we got everything else down that we needed, and we'll talk more later.